So, as we have to have lunch at 1, we have decided to postpone Mrs. Luana's presentation to this afternoon. So now the time has come for Fulvio Sinisi, who will speak about Silver tarnishing protection, state-of-the-art, and other studies. So after graduating in Padua in 2016, he started to work at Legor, where he is now R&D manager. And he deals with formulations of new techniques, improvement of already existing projects, and he also manages the technical support for the plating department. So we will have a presentation on silver, who is subject to oxidation and tarnishing. And the presentation assesses the situation from the physical and chemical viewpoint and possible techniques, anti-tarnish techniques. And we will see a case study showing the different ability of various methods in order to improve tarnish resistance. And the objective is that of offering an overview on the state-of-the-art of the current solutions and the importance of advanced tests in order to improve the protection of silver.
Grazie mille e buongiorno a tutti.
Well, hello, good morning. As Andrea already said, we will focus on silver tarnishing, starting from the description of the phenomenon, the removal of the tarnish, anti-tarnish treatments, and evaluation of the efficacy of these treatments. And then I will show you a case study during which various solutions, various technologies have been tested related to silver tarnishing. And we will see the various tests and the different performance of these different tests. Well, silver has long been used for the production of precious jewels, and this is due above all to the fact that silver is the metal with the highest brightness, and so it can have brightness. And it is a metal which is easy to use. It has a long duration resistance, and although being a precious metal has a relatively lower cost if compared to gold or platinum, and the motivation is also related to its abundance in nature and lower mining difficulty, above all compared to gold. So, although being a precious metal, silver is subject to some reactions which can change its aesthetic characteristics. This is called tarnish, and it is a spontaneous reaction between a metal and a non-metal, oxygen or sulfur. In the case of silver, the tarnish reaction is described by this chemical equation where silver reacts to sulfur. Sulfuric acid is identified without atmosphere, thus giving rise to silver sulfur, which is the tarnishing. Well, we should specify that this phenomenon is a very complex one because it involves a whole series of reactions which take place simultaneously. And the identification of sulfur composites is not enough because there are various composites which intervene in this reaction. Tarnish is a surface reaction. It involves only the first layers of a silver surface, and according to the thickness, there are various colors from yellow to black, which is the real color of sulfur. Well, there are various reasons for that. Certainly, the concentration of tarnish compounds, which increases the level of tarnishing, thus accelerating the kinetics of the process. And also temperature plays a very important role, because temperature itself is a variable which contributes to process kinetics, and then it increases the pressure of sulfur vapor, and humidity, although not present in the reaction, has in fact a very important impact on the tarnish of silver, because the absorption of water vapor is the perfect means to accelerate this type of reaction. And then certainly the purity of silver, because often silver objects are alloyed metals which have a greater reaction to sulfur compounds. So an impure silver object is more subject to tarnishing as compared to pure silver or galvanized silver. Well, the thickness is itself a barrier. And as a consequence, the greater the thickness of sulfur, the slower the reaction. And indeed, the tarnish reaction is a self-limiting phenomenon which involves a low layer of the surface, and it is possible as a consequence to remove the tarnish layer, which will not attack the whole bulk of silver as can happen in iron. And as a consequence, once you have removed the layer, the surface of silver will show its proper chemical and physical characteristics. But of course, as the silver layer is exposed to atmosphere, it will be subjected to tarnishing. Well, there are various techniques. You can use abrasive systems, and the notion is that of mechanically removing the tarnish layer. Well, a certain portion of silver will also be removed. Well, of course, it's a very small quantity, but we have to underline that. There are also other systems, chemical and electrochemical systems. Here, for example, we have a homemade system based on electrochemistry where aluminium is involved. And what is suggested in many sites and meetings is that of plunging the silver objects in contact with an aluminium paper, thus exploiting the reaction, the chemical reaction. Well, it's a process which has not a high level of reproducibility, because there are a series of actions which can make this process non-effective or even allowing for a new deposition of this problem. And then there are chloride, peroxide solutions. These are very aggressive products. They can attack the underlying surface. Well, you can also use common detergents you can find in all shops, and these are based on the presence of some mineral salts which have a modest abrasive function. And sulfur is bound by some chelating agents, and aggressive molecules are dispersed. And then there are industrial products which use reducing agents which reduce metals. There are chelating agents which bind sulfur, and then corrosion inhibitors which avoid the reaggression of silver for a long period of time. Now, as a consequence, Well, we have said that tarnish is a spontaneous reaction of silver. So even if you remove it, the surface will still be subject to tarnishing. So what you have to do is to slow down or avoid this type of reaction. It's impossible to stop this process. And so our approach is that of preserving the object with a certain care, avoiding the exposure of these objects to pollution or atmosphere, and then use some anti-tarnish solutions. Well, there are various products, various technologies, all based on the same principle. That is that of creating a barrier in order to avoid the contact between the surface of silver and tarnish agents. So we used silver objects. In some cases, polymers were used or passivating solutions were used. And finally, recent studies have focused on the use of new technologies for the deposition of nano substances. Well, rhodium, for example, has a high resistance to tarnish with high chemical inertia, and then it is a precious metal, and so it increases the final value of the object. The problem is that the thickness applied is lower than 0.2 micron, so the resistance is guaranteed, but only for a short period of time, because the thickness will tend to be removed, and the surface of silver will be again subjected to tarnishing. And then rhodium is a white metal deposit, but it is less so as compared to silver. So if we had to express the white color with these CLA activities, well, rhodium has an L equal to 90. So we have a certain level of resistance, and then the final cost increases, and it is subject to the oscillations of rhodium costs. Well, the application of organic polymers make it possible to have a good defense because there is a high thickness beyond 5 micron. Systems of applications, we have various types of applications, and the costs are low. The big problem of this type of material is that it is a plastic material, and it gives the objects a plastic aesthetics, and as a consequence, and then apart from being transparent coatings, the thickness is such that it changes the reflectance of light, and so the final effect is that of a color which is much darker. These are more complex processes as compared to rhodium. There are some difficulties in the application, and you have to have higher qualified staff. Now, the most used systems are so-called passivating solutions. In the past, CR6 solutions were used with a high resistance to tarnishing, but they are based on CR6, which is highly toxic. And then other solutions have been used. Benzotriazole, for example, is more prone to copper than to silver, and so it is often used for copper alloys in the electronic sector. Organosilicates are effective, but the problem is that they are difficult to manage because they are dissolved in solutions which are difficult to handle, and they are not so stable as compared to other solutions which are much more used for passivations. And these are TiO-based solutions. These are compounds based on carbon atoms. So there is a connection. And these compounds are called self-assembled monolayers. These are molecules which interact with a metal surface and can be absorbed and can organize independently as to create a homogeneous layer. In terms of silver, these are very useful because they can bind to the silver surface and they create a connection, a bond, and they make the surface hydrophobe, thus slowing down the absorption of humidity and the interaction of the surface with the sulfuric compounds. Thickness is small, so you have invisible layers which maintain the brightness unchanged. These are very simple to use and low cost, and they are low cost methods. And they are today the ideal solution to preserve silver objects. The great disadvantage is the small thickness, which means that they have little resistance to wear, and so they are not the ideal solution for many situations. Recently, vacuum technologies have been developed with the objective of depositing a barrier, thus avoiding the interaction between silver, humidity, and tarnishing agents. The methods of applications are two, and they are called TiO or PVD or ALD, physical vapor deposition, which grows a material on a layer starting from the evaporation and successive condensation in a vacuum system, starting from a target which is eroded and evaporated. We have a growth of a few microns per hour, and the temperatures can be as high as 1,000 degrees per centimeter. And then for anti-tarnish coatings, we can use ALD, which means atomic layer deposition. It is a technique which grows single thin layers by means of impulses made with gases and inert gases. So a series of cycles which produce homogeneous compact layers with the very high growth rate. And in this way, I can control growth by means of chemical reactions, and I have a high level of control of the growth, and the pressures and temperatures involved are less high than DVD, and also pressure is lower than DVD. So this technology makes it possible to create high resistance barriers with the low thickness, 15, 40 nanometers, and such a small thickness can be very effective. And there are studies which have demonstrated that the same deposit has the same resistance with a similar deposit made by PVD and deposits above 5 micron made with normal polymer-based resins. And this makes it possible to control the thickness and control also the compactness of the layer. So in the case of higher thickness, there can be an impact on the aesthetic characteristics of silver, so you have to use thickness lower than this value. These are highly specialized techniques based on vacuum techniques, and there are high costs in terms of technologies, and also the staff must be highly qualified, and all these costs may have an impact on the final cost of a silver object. Now, in order to assess the resistance to tarnish of all these systems, tests have been developed. The most frequent tests are those where the silver surface is exposed to sulfur. It can be vapor or immersion in solutions, sulfur sodium or potassium sulfur. Now, it would be appropriate also to check the resistance of these objects, exposing these objects to other compounds, whether it's chloride or whether there is humidity or ultraviolet reactions. And it would be interesting to carry out a real-life test to all the possible complex situations. Now, all these tests are not specific for silver. They are used in other sectors. So today it is very difficult to define objective criteria to assess the efficacy of these anti-tarnish treatments. The assessment is normally based on tests which include the exposure to sulfur. And there are some difficulties in interpreting these data because the same treatment often has results which are very different from other tests. So today the approach used is that of having a series of tests, different tests, hoping that there is a certain correlation between similar tests, so as to identify the efficacy of the anti-tarnish operation. Now, I'd like to show you the results of this study that we carried out at Leger with the objective of comparing 8 passivating solutions taken from the market, all based on SAM systems. Different sterling silver layers were tested, and we did TAA tests and the immersions in 5% sodium sulfur solutions for 20 minutes. Now, results were assessed in a visual way, but a more objective evaluation was made with the use of a spectrophotometer. These are the results after 48 hours. And what emerges here is that there is certainly an anti-tarnish effect in passivating solutions tested, because we see the difference in color between the non-tested product and all the other products. But it is impossible to differentiate the efficacy of the various treatments, because all the compounds have had good results, and it's difficult to say what is the best sample. And then this test was made, and in this case, after the first 5 minutes, we could see differences between the various products. And at the end of the test, lasting 20 minutes, results were confirmed. There were no significant changes. And if you look at the L value, which is the brightness and the white color of the silver alloy, well, you can see that there is a difference between the various treatments, and after the first 5 minutes, results are evident. 3 samples overcome the test with a brightness greater than 95, and all the other samples did not did not achieve the same results. Now, in conclusion, what are the next challenges? Well, first of all, we will have to establish a series of tests specific for silver tarnishing. We will have to have the most accurate possible simulation of the real exposure conditions, and then we should have a correlation between the test results and the life of the object, because very often customers ask us how long will the result remain? Well, for us it is impossible to give an answer because the tests which are made do not give these types of results. They are comparative tests, but I cannot say how long an object would last. So having tests which can give this type of answer would be very interesting, because it would promote the development of new anti-tarnish treatments, invisible treatments with a high resistance to tarnish, and also lasting over time. Thank you.
Ringraziamo dottor Sinisi. Concludiamo quindi la sessione del mattino.
Thank you very much, Mr. Sinisi. We're going to meet again at 1:45. Light lunch is served just outside this hall. Thank you very much, and see you soon at 1:45. Thank you.